As I say, I'm going to be. I have scheduled a bunch of tweets, various blog posts and things that I'll talk about during the during the presentation. They'll be going out on the Twitter feed. At this point, I should probably put a warning in. At a lot of SQL Server events, it's kind of frowned upon to talk about open source tooling or commercial tooling or whatever. I'm talking about release management for SQL Server. So to a certain extent, I'm not talking about SQL Server itself. I'm talking about how we deploy that. It's kind of impossible to do that without talking about software that's going to help me do that deployment. Now, open disclosure, I do have various associations with various providers of software that do that. I'm going to try and be very BBC about it. So I am going to talk about open source software. I am going to talk about various third-party tools. I am going to talk about some Microsoft tools. I'm going to try not to be biased about it. If you don't want to hear any of those, I want to be as fair as I can. There are a bunch of other good sessions going on, so this is your opportunity. I won't be offended if you do want to go and watch one of those sessions instead. Who here has read any books on software in the last 20 years? Come on, one of you must have read a book on software in the last 20 years. Okay. Did it have any of these words? Yeah, mostly. So we've come up with a whole bunch of words for a whole bunch of good, clever things to do, such as release more frequently. Try not to let changes batch up into big, try not to let changes bulk up. Try to work together better with other teams in the business. And we've come up with various, I should probably add DevOps to that as well. We've come up with various different words to basically describe, we want to be quicker at delivering software. We want to deliver software in smaller increments. We want to learn from those decisions. We want to do it better than our competitors do. And these books are generally written for developers, the sorts of books that have got these words in them. And they're kind of counterintuitive to what DBAs care about. How many developers have we got in the room? Okay, and how many DBAs have we got in the room? Yeah, 50-50. So when I wrote this presentation, I had to choose, do I put this on the dev or a DBA track? And I said, look, I'm on both tracks. This is a dev, and like the whole problem of DevOps is when we start splitting things into that's a dev thing and that's a DBA thing. No, we are all responsible as a team for delivering the changes that the business needs and not breaking stuff along the way. Part of what I'm going to be talking about today is very much about bringing those two teams closer together and having a consistent way that both teams work together to handle the changes right from development through to production. Talking about the two different silos, the developers on one side, DBAs on the other. I won't put you on one side or the other because it'll be like England and Russia or something. This ever happen in your organization? Has anybody never seen one of these? Okay. And has anybody never experienced it when some person at the back of the room puts a hand up and says this? I'm judging by the laughs that happens a reasonable amount. Sometimes the developers will point the fingers at the DBAs will point the fingers at the developers. I have the skills, you don't. You just can't do that on production because that's the sort of thing that's going to work fine while you've only got 5 rows of data in your database. Yes, of course, the stored procedure works fine, but as soon as you've got 1 million rows of data, it's not going to work very well. But it's not always that way. Sometimes the finger goes pointing the other way. Who has a DBA who has occasionally made changes on production and not communicated that back to the developers? Yeah, we call that database drift. I'll talk about that a bit more in the future, later on in this talk. But when we end up with these different inconsistencies in different environments, when everything's not joined up very well, we get all sorts of problems. And they're the problems that I'm going to try and talk about today, talk about how we solve them. I'm going to put this in the context of a real-world organization. Now, I've been working at Redgate for the last 6 years. I've worked with hundreds, if not thousands, of companies in that time across 6 different continents. So if you know anybody in Antarctica, I'm still hoping to tick that one off. If any of you know anyone in the scientific mission down there and maybe they've got some SQL databases I can go help with. But this is one company I went out to help. So these guys are Farm Credit Services of America. They manage financial incentives and tax relief and stuff for the agricultural industry in the American Midwest. And as you can imagine, that's a pretty big industry in the American Midwest. If you've ever flown over it, it's just fields. So it's a pretty big business. There are about 100 people in their IT team, a mixture of developers, DBAs, database engineers, various other different roles that are popular right now. And within those 100 people, there are 14 different sub-teams. One of the things they did that I quite liked is there's a DBA embedded within each one of those teams. It was quite nice to get kind of... They're quite forward-thinking. But they still had 14 different teams, all of which was able to manage their database changes in their own way. Now, all of these different 14 teams ended up pushing changes to the same set of databases. And the guy on the left is a guy called John Morehouse. He's a SQL Server MVP. He's a PARS chapter leader. He manages a bunch of the SQL user groups in the American Midwest. He's a big guy in the SQL community, if you've ever worked with any of them over that way. He was a production DBA at this company, and he was being thrown scripts left, right, and center and say, we want to put this on production, we want to put this on production. Some of these scripts came from source control, some of them didn't. Some of the different teams used different sorts of source control. So there was SVN, there was TFS, there was Git. Among these 14 different teams, there's all sorts of different flavors of source control systems being used. They also had all sorts of different processes for how they put their codes in source control. Some people would put the migration script that they want to add. Some people would put how they want the code to look once a migration script has been run. So it was impossible for John to be able to keep track of all of these different changes that were coming at him from all these different angles. And of course, they all had to be deployed within a couple of hours. So what they did is they wanted to bring Redgate in to try and help them work out how to smooth things along, how to be able to deploy more frequently with more reliability, how to avoid making mistakes. And what we came up with, if you look at the whiteboard behind us, this is what we came up with. This is the plan that we're going to put together. We're going to standardize our source control process. We're going to use some sort of automated testing process, some sort of automated build and CI process. The output of that was going to be some sort of package that was going to be deployed to the various different servers. I'm going to jump to the next slide because this is a easier to read version of the same thing, and this comes straight from my company's marketing slides, but this is the typical sort of diagram that you might see anywhere in any continuous delivery book about how a build process should look. Okay, and they're the same basic ingredients that you see everywhere. You've got source control here on the left, so that is in a light grey box on a white background, but apparently you can't see it, so I'm afraid that's going to become a theme of this presentation. Sorry about that. But the point is you've got all the developers over here putting their code into some central repository. All of the code goes to the same place, in the same format, in the same way. We have one source of truth. From that source of truth, we can trigger automated builds and tests and things. The output of that is what eventually goes onto our production servers. That is how the pipeline is designed to look. Let's talk about databases. How many people have done that for their database? Precisely. Nobody does it for their database. I've done it for the database in a couple of different ways. Yeah? How did you? What sort of approach did you take? That framework. Okay. So there are various different problems that you're going to come across when you try and apply this to a database. It's not as simple as application code, where you just package up your binaries, throw them at the server, point IIS at the new location, and you're done. When we deploy databases, it's funny, they've got this thing called data inside them. We can't just drop the old database and deploy a new database because there's data we need to worry about. We'll lose the data if we do that. So we have two things we need to think about. We need to think about where we want to get to. We also need to think about how we get there. And that is the root of a fundamental problem when we're trying to do database deployments. What's more important, the migration script or the state that you want to get to? What is your source of truth? What's the thing that you put in source control? Do you layer up a bunch of upgrade scripts and run them in sequence? Do you define how you want it to look, like SSTT does, and then use some software to upgrade you? And most sessions that I go to, when somebody tells you to do something like this, they will say one or the other is the correct way to do things. I'm going to call their bluff. I'm going to say anybody that tells you there's only one way to do things is either doing it wrong, or they don't know what they're talking about. The point of the matter is there are a bunch of people that, on both sides of this debate, who are very, very smart people and for very good reason think their approach is right. That's because one approach is better for some sorts of projects, and the other approach is better for other sorts of projects. And I'm hopefully going to help you understand which is better for you. Other problems that we're going to run into, reference data and production data. Reference data, lookup tables, static data, that wants to go from development up to production. But your production data wants to go in the other direction, because for testing I want to grab down either production data or production-like data, which is safe for me to use for testing. We've got problems to do with teamwork. If all the developers are working on the same machine, on the same database, on the same shared database, well, no source control system in the world can help me if I overwrite the code before it even goes into source control to help me manage conflicts and things. And then we've got the database drift problem that I mentioned before, drift being where a change happens outside my process, where somebody fixes the bug in flight in the test environment rather than doing it in source control, where a DBA makes a hotfix on production. They're basically going to destroy any chance that you have of building up a decent release management process. We need to stamp that out. So this is the agenda. There's quite a lot to get through. It's a 90-minute session, probably about 10 minutes in now. This is the agenda that we're going to work through today, and really the meat of it is, that's a rubbish little light, isn't it? Really the meat of it is going to be here when we actually start talking about how we deploy and then how we automate that deployment. But in order to get there, I do want to cover some of the basics. It was in the abstract today that I'm kind of assuming you've got your databases and source control somehow. I'm not going to labour the point on source control because it's 2016 already. If you don't have your databases and source control, be ashamed of yourselves. Okay? And I'm not even saying that with a smile on my face now. I'm saying that seriously. We're then going to talk in detail about migrations and state. We'll stay there for quite a while, and then we'll work our way through. So let's get started with source control. As I mentioned, it's where we put our code. It's the very source of everything. If we don't have a database and source control, that's the first step, because there's no way that we can automate the testing on our code if we don't know what the code is. There's no way we can automate the deployment of the code if we don't have a defined source of truth to get it from. Now, let me Google that for you. There are a bunch of different source control systems. Pick one. Basically, nowadays, you're basically going to pick TFS or Git, or TF-Git, which is kind of a hybrid that sits in the middle. I don't care. Pick a source control system, start using it, start saving your code to there. But the interesting thing isn't which source control system you choose, it's what you put into it. And this is what I got onto before, the migration or the state. Okay, so when I first created this slide, I had my actual kitten. So our cat is now about 5 or 6 years old. But when my wife saw the slide with our kitten, and there's more than one way to skin a cat, she made me change it. So that's not our cat anymore. And she also made me correct another part of this slide as well. But the point is, as I say, there are a couple of different ways to do it. And as I say, this is our main problem. The migrations-based approach is where it's the upgrade script that is our source of truth. And it's the state-based approach where the state that we want to get to is our source of truth. And as I mentioned, different people have different opinions. And what is the reason why people so strongly believe in one approach or the other? Well, I'm going to summarize it with a couple of quotes. Paul Stovall, does anybody use Octopus Deploy? A few people. Okay, Octopus Deploy is an example of a release management tool. I'll talk a bit about release management tools later. It's just one of several different release management tools that you might want to use. He's an influential character in the .NET community, lives in Australia. And in his opinion, there is nothing more reliable than keeping track of exactly the scripts you intend to run and running them without trying to compare state and guess. And that last bit is a reference to software that compares two different databases or states, generates a script, and executes it. Because you know what? Sometimes software has bugs. Sometimes it doesn't work. Okay? And that's fair. Sometimes it doesn't work. So there is nothing more reliable than keeping track of the scripts you want to run and running them in sequence. And he's right. There is nothing more reliable than that. If you can do that, brilliant. Okay. However, Gert Draper's Microsoft guy, he's a guy that built DataDude, which is what later became SSDT. In his opinion, as soon as you have multiple changes on a single aspect of an object, ordering and the ability to detect which change needs to be made gets very complicated. That's very true as well. If I've got lots and lots and lots of upgrade scripts, then we all know it's important to get the order right. And how am I going to check that without reading every single upgrade script and cross-referencing them all? And then that gets a complicated task if you've got lots of upgrade scripts to handle. If you've got different people working on different branches for 2 or 3 weeks at a time, that's a difficult job to integrate those at the end of the day. It's hardly continuous integration. So both arguments have got a point. Okay. So what I'm going to do, and actually this is a blog post that I wrote apparently on June the 18th, 2015, and apparently I haven't tagged it yet. That's bad. It's gone out on the Twitter feed, so if you want to read the full blog post on this, it's there. There's also an hour presentation that I did at NDC Oslo last year, which is basically covering this topic in an hour's depth. But I'm going to demonstrate the difference between migrations and state and the different sorts of problems that you're going to have with an example scenario. Okay, so I'm working on, so my team for this example scenario, I run a website that allows you to find the nearest cat trainer in London. Okay, and so there's a view in here that finds all the cat trainers near London. And I've had a request in from one of my clients. It's really important. It needs to go to production straight away. I need to add to this view. I need to find the information whether they accept tiger cubs. So I need to add this to the view. Okay. In a separate stream of work, a different team also has the for their own requirement has to split a column. And we've got trainer full name, and we need to split it into trainer first name and trainer last name. Now this is probably kind of database refactoring 101, kind of this, what we're going to have to do here. We're going to have to do we're going to have to create the new columns, first name, last name. We're then going to have to do some sort of data transfer where we split the string based on where the space is, put them all in there, then we can delete the old column and we've got the new one. That's kind of the exercise that we're going to have to do this change. So the different teams are going to work on these separately. And let's see whether a migrations or a state-based approach is going to work better. Has anybody got any ideas about which one's going to work better? You reckon? Migrations if they're using branching. Okay. Anybody else? Okay, well let's walk through. So let's go with migrations first. So first developer comes along and they add they alter the view and they alter it so that we accept tiger cubs. Okay. And the next developer comes along and they're going to alter the table. I've commented this out here. Well, I've not commented. I've just left out the fun with strings because it's a little bit big to fit on one slide. But they're going to alter the table to split the column. And then because there's this dependency, the view is going to look at the table. We also need to update the view so that it reflects first name and last name rather than full name. Who can see the problem? Pardon? Yes, you are. The first developer had added the accept tiger cubs. Now this developer didn't know about that change, so when they changed it, they didn't include the new column, and we have a conflict. With alter statements, the last one wins. The last script always wins. So you need to spot this. But if every single change is a new upgrade script that's been applied to the database, that's not a trivial thing to do. It's quite hard. And the more teams you have, and the more scripts that you have, and the more development you have going on, the more hard it becomes. Which is why, when you've got lots of changes going through a database, this approach can fall down. When you've got a very large development team, this can become quite hard to manage. So clearly, migrations didn't work, so let's see if state can solve our problem. Let's see if we use a state-based approach, whether that's going to help us. So we're going to start off with a view. Let's start looking at that view, because that's where we had the problem before, the view that defined the alter statement after the alter statement caused a problem. But now we're working in a state-based world. We're thinking about create state statements. We're defining how we want it to look. So we're probably working with create statements. Create view as kitten trainers as select full name from kittens. That's the original version. Then the first developer comes along and adds accepts tiger cubs. The next developer comes along and handles the dependency by splitting the column. And we still have the problem. But now, because we've been working on the same file in a consistent way and we've been working on different branches, there's simple diff tools that can help us merge the stuff back together. That's a solved problem. Okay, source control systems are really, really, really good at spotting changes to a consistent set of objects. Git, if you use Git as source control, is going to handle that merge for you automatically, probably. So that is kind of a solved problem now. But let's look at what's going to happen with the table change. Okay, so what we end up with is, there's a little bit too much text on this slide, I apologize, but we've got the create table on both sides with the full name over there and the split columns over here. And then we've got the view down here. You've got the original version and the new version that now has everything because we've used a diff tool to merge those changes. Okay. Now, if I'm using a state-based approach, I am probably going to use a software tool to generate the upgrade script. Maybe I will write it myself, but most of us now are going to use Visual Studio Schema Compare or one of their competitors to work out an upgrade script to handle that deployment. And what problem am I going to have? Anybody? The data, yeah. So this is... My battery is low. I didn't plug it in. That'll be why. 1 second, sorry. Mess. This isn't very smooth. Full name, alter table, add the new columns, and then we'll change the view. That's a problem because we had data in that table. The reason migration scripts work so well for this is because I was able to provide the script I needed to split the column and move the data and handle all the data underneath. So with migration, with a state-based approach, when you're using software to generate your migration scripts, it's not a complete solution because there are some scenarios where no matter how good the software is, it's not going to be able to work it out. I mean, the different vendors are going to compete to try and solve more and more and more of these problems as neatly and easily as possible. Like, for example, table renames is a common one historically that diff tools tended to miss. Nowadays, they're trying to compete to be able to spot that. So it's not a drop and a create. It can work out there are two tables with the same data in the same columns, so they can spot that. But there are some things they're never ever going to be able to fix, such as I want to create a new not null column, and I want a specific sort of data to be my... I want a specific sort of data to be my default, or I want to handle this column split in a particular way. I just want to do just data-only data migration. So there's some sort of stuff that diff tools are never ever going to be able to work out. So given that, it needs to be obvious to you if you're going to use one when it's not going to work, and you need to have a plan B for what to do in that scenario, and testing for data loss is probably a good thing to do to build into your process, because you don't want to accidentally be dropping columns or tables. Okay. So which is better? Again, there's supposed to be data, but it's kind of light grey on white, so I apologize for that. Which is better, state or migrations? And the answer is, well, they both have different problems. So which are the problems that you want to have? Okay. In general, if you associate yourself more with the stuff on the left, you're probably going to get on better with a state-based way of working. And in general, if you associate yourself more with the stuff on the right, you're probably going to like migrations more. But nobody is 100% on one side or the other. Define the difference between a large and a small team. Okay, I can say that 1 is small and 100 is large, but where's the line in between? Especially if only a certain number of people are touching the database. How many is too many scripts? How many stored procedures do you need before you're better off working in a state-based way rather than a migrations-based way? It's all grey. And different people will have had different experiences and will have had different battle scars, and for those reasons, they'll have their own beliefs about which one is right and which one is wrong. But my fundamental message to you is neither are right, neither are wrong. It's just grey, and pick one that you think is better for you. Okay. That said, there are a bunch of tools that we're going to use, and it would be remiss of me not to point out, look, if you want to go down one of these paths, where's a good place to start? Well, if you want to work in a state-based way, SSDT. It comes free out of the box with Visual Studio, and that's what you're doing. You create a database project, you define how you want your tables, and you store procedures and things to look. You generate a DAC pack, and then you can throw it at a database server. It will generate the script for you, and it will deploy it. That works in a state-based way of working, and it's fantastic for an awful lot of teams. It's made it an awful lot easier to work with from a development point of view with SQL Server. But people who have tried to do full-on automation, full-on DevOps with it, have often struggled because of the fact that often you need to rename the script, you need to fix the upgrade scripts. So it's not necessarily suitable to full-on automation. Migrations frameworks, on the other hand, are perfect for automation. They're very well aligned with it. Pretty much everybody in the Linux space is doing migration stuff because they're all about automation, and that's what they think is the best way to solve that problem. But if you're working in large teams, then it's difficult. I have got some pictures here as well. Good. Again, I've got some links going out on Twitter to DBUp and Flyway. There are a couple of open source frameworks. If you're going to do the migration thing, by the way, it is tempting to want to write it yourself, because how hard is it to write a script that runs your upgrade scripts in sequence against some target database, sticks a table on the target database, it keeps a log of which scripts have been run, and then you can just run from there. It's not that hard. At the same time, there have been people who have been thinking hard about this problem for quite a long time, and they fixed the various bugs that they've come across along the way, and I guarantee you that they will have done a better job than you can do in half a day. So since this stuff is open source and free, and you can contribute to stuff that's already there, if you want to do this, I strongly recommend you use one of the existing frameworks rather than building your own thing. There is another class of solution. There are a bunch of tools that are kind of hybrids that try and take the best of both worlds. I'm not going to go into them too much, for obvious reasons. If you want to come and speak about them, then come and find me afterwards, but I don't want to be that guy that does a presentation and sells his own stuff. So, we're going to pick a deployment process based on either migrations or state or hybrid, whatever you want. You're going to pick the process that you want for the actual deployment, but how do we actually plumb it all together? Because it's one thing to say, what tool am I going to use to handle my deployment? It's another thing to say, right, how do I actually automate that? What are the bits and pieces I need to glue all this stuff together? So that's what we're going to talk a bit about next. Now, first of all, that's not what we're going to talk about next. Next, we're going to talk about Drift. What we need to understand is how Drift is going to affect my deployment if I'm working in either a migrations or a state-based world. Because in order to tackle the problem, we need to understand the problem that we're going to have. So Drift is where, as I say, people are making changes to the endpoint databases without going through the whole process. Do any of you work with this guy? What he's doing when he's doing this, and a very smart person once said, when making changes directly on production, you are making a decision that the delay due to poor cycle time is more expensive than the risk of making a mistake. Smart guy. Who knows what I mean by cycle time? Do I need to cover that? Okay, so cycle time is, if I was to say to one of you, I've got a one-line change I want to make to the database, I'm going to start in development, how long will it take for that to get to production? That's cycle time. How long does it take to get it into production and start getting feedback off it? Okay. If that time is measured in weeks or months, it's way too slow. You want to get that to be measured in minutes, hours possibly, but preferably minutes. Okay. The reason being, this guy here has seen there's a problem on production, it's costing my business X number of $1 billion a second. Okay. At that point, is it more expensive to make the change directly on production? It's an easy change. I'm only adding an index. It doesn't count. Is it the risk of making that change, is that more expensive than leaving it there for 2 months while I wait for 15 people to approve the change before it can go to production? Well, if it's a low-risk change, and I can either do it in 5 seconds or I can wait 2 months, well, I'm going to do it straight on production, aren't I? If people are making those sorts of decisions, it's because your cycle time is too long. You need to get your cycle time down. You need to be able to get to a point where you can make a change. If you need approvals on it, if you need to build your database, if you need to test your database, you need to be able to get that to happen in minutes rather than months. Because at that point, he doesn't have an excuse to make the change directly on production. You can trying to lock down everybody's permissions, trying to lock down everybody's credentials, trying to do all the things that people normally do to basically stick a big wall up in front of production is only fixing the symptom. It's not fixing the fundamental problem, which is the reason people are doing it, is because it's the only way the business can fix a leak of money quickly enough. Okay. So what bad stuff happens when drift occurs? Well, if something changes on production and it's not spotted, as almost always it's not spotted and it's not documented properly, it doesn't go back into source control, you're typically going to have one of two different sorts of problems, and it's going to be related to whether you've gone with a migrations-based strategy or a state-based strategy. So if your deployment strategy is, here's a model of how I want my database to look, make it so, like a state-based world, I'm going to be rolling back that hotfix. Now, if it was an important enough hotfix that it was so important I put it on production that it's worth me bypassing all of my usual development processes, somebody's going to be pretty annoyed if I accidentally roll that back, because for whatever reason that hotfix was put in is going to revert, and I'm going to have that problem again. So state-based doesn't handle it very well. And if I'm working in a migrations-based way, well, I'm just going to keep on running these upgrade scripts regardless. And so I'm going to end up with a state on my production database which is unlike anything I have in source control, anything I've ever tested, anything I've ever seen. It doesn't take a genius to work out that ending up with something on production that is unlike anything you've ever tested is probably a bad idea. Now, I don't know what the problem will be, but you'll find out one day. So that environment inconsistency is very dangerous. I mean, the example that's always quoted is the Knight Capital example. I should have tweeted that. I forgot to do that one. If any of you are interested in the damage that environment inconsistency in code that's left on production can do, just Google Knight Capital software bug. It was a trading algorithm at a company in the city that ended up going haywire and trading, and they couldn't work out why the problem had occurred, and about 4 hours later the company had lost over $1 billion. So that's a very extreme example, but environment inconsistency can and will bite you at some point. So basically drift is bad whatever you do. Just stamp it out. There are some things you can do to help. As I mentioned before, improve your cycle time. Invest in DLM processes, in source control and CI and release management. Get to the point where you can deploy your stuff more quickly, because then there's less excuse to make the decision to make the change directly on production, and you're more likely to go through your regular source control processes. Strict security policies, as I say, lock out the people who are making the changes. As I say, that is kind of fixing the symptom rather than the problem itself, but there you go. It is quite easy to set up alerts by yourself. Play with DDL triggers, get it to send some message or something whenever the database changes. Tie that up to your email server, get it to send you an email. Or, I don't mind mentioning this tool because it's a free tool. I'm not trying to sell you anything. Redgate does have a tool called DLM Dashboard, which you can just go to the website. It will have gone out on the Twitter. It's just free. You can download it, and it'll start sending you emails whenever any of your databases change, telling you exactly who made the change, what the script was, and when it was made. So feel free to take a look at that. But just spotting that drift is occurring is, as I say, it's dealing with the problem, but it's not dealing with the root cause. What we should be doing instead is going through source control, going through CI, going through release management. And I keep mentioning this CI thing, this continuous integration thing. Now, I did also say in the abstract that hopefully all of you are doing CI already, but I'm going to guess that not all of you are. So just to quickly go over to continuous integration, which is this middle bit. And I'm going to start by giving you a definition. This is a definition by ThoughtWorks. ThoughtWorks did not invent continuous integration, but they certainly did a lot to publicize it. And they definitely deserve a lot of credit for that. Continuous integration, CI, is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. So the idea is that if you work down different tracks, the integration point of any project is always a horrible part, right? We should be integrating our changes all the time. Everybody should be committing to mainline, not to their feature branch, but to mainline several times a day and running various different tests on it. That way we know that my change hasn't broken your change, which hasn't broken your change. Okay. As a result of that, it's also a great platform to start building automated test framework. Who here does unit testing on their database? Fantastic. That's more than I get at most places. It's still not enough. Would any of you hire a .NET developer that didn't believe in writing tests? People are staring at me blankly and shaking their head. Of course you wouldn't. Like JUnit, NUnit, XUnit already. Start using it. The frameworks are there for SQL Server as well. They're called T-SQL-T, TST. It's built into Visual Studio. There's no excuse not to be starting to write some level of testing if you have any business logic at all in your database. Anyway, that aside, this sort of framework is a really great framework to build that on if we're carrying out automated verifications and builds and tests every time somebody commits to source control, so that you know as soon as you commit to source control whether you've broken something, or at least you've carried out the first pass of tests each time you commit to source control. There are a bunch of continuous integration tools available that try to help you realize that theory. Now, it is very important to understand the difference between setting up a build server and the idea of continuous integration, just because going around Visual Studio Team Services or TFS, either online or on-premise, TeamCity, that one is Travis CI, Bamboo, which is by Atlassian, out there, Jenkins, they're all good, open source, commercial stuff, Microsoft. There are all sorts of them. They all do pretty much the same thing. Just because you're using one doesn't mean you're doing CI. Basically, these are fancy task schedulers, and if you use them according to the theory of CI, which is everyone commits into mainline, you use your CI server to trigger a build and run some tests, and wonderful, you're doing CI. But it's very easy to use one of these and not properly be doing CI because you're doing like nightly builds, or because you're using it to not fully test your database or whatever. Anyway, so there are a whole bunch of tools out there that can help you do this. How they look under the hood, what they actually do, this is the process that we're typically trying to automate. We see that there has been a change in source control. We carry out some build. Now, in the .NET space, we're thinking about compiling our binaries. In SQL, pretty much the same thing. Our code is there as SQL statements in source control, and we need to build the database. If we cannot build the database out of our code, we're not doing continuous integration. If we cannot truly build the database from our source code, we're not in a very good place to start with release management. Now, that includes if I need my server to be set up in some funky way, if I have 15 different databases with some complicated web of dependencies, so I need to build them in some complicated order, that's included. Okay, we ideally will get to a point where each database can be built by itself, so that we can test it in isolation to see whether we have, for example, got a broken dependency in there that means I can't deploy it, to see whether I have some problem in my source code, just a typo because somebody's gone into the source code directly and now something doesn't compile properly. Okay, so we're going to build it first. Generally, this is going to generate some sort of package for us. So if you're using the Microsoft stuff, the SSDT stuff, we're going to be creating a DAC pack over here, which is basically just a zip file with all the scripts in it and various other bits of information. A lot of other people like to use NuGet packages. That's kind of a default standard for Microsoft. If you've never heard of NuGet, they're basically, I would say, just fancy zip files with a manifest in them that has kind of version number, author, license information, dependency information. It's a really handy package format. But this is typically going to be your deployment artifact, the thing that we will later use as a foundation of our deployment. When I say I'm going to deploy version 74, what I'm going to do is I'm going to go and get package 74 from my CI server, which I know has passed all my tests. I'm going to throw that at the production server or the test server or the staging server or wherever I'm going. Other things we're likely to do, run unit tests or performance tests or whatever other tests we want to carry out, possibly give us some test results out the other end. We might want to be auto-deploying to various environments. It's nice to have a database that's always up to date with the latest state of affairs. So if all my developers, for example, have got their own local copy, it's nice to have an integration database that is automatically deployed with all the latest changes. That's quite useful for testing. So that's typically what our CI server, that's a process it's going to orchestrate. Well, how is it going to do it? Well, this is how a CI server looks under the hood. Do you guys know all this stuff, or is this new? Okay, so some of it's new. Okay, I'm glad to know that I'm not just preaching to the choir. So a lot of people get terrified of build servers and CI servers, and they're these big scary things. I don't know how to use it. There's some sysadmin somewhere that does that for me. They're not that complicated, okay? I simply install some software on a server that's like a task manager, okay? Based on some trigger, I'm going to carry out some automated action, okay? Based on when somebody commits to source control, I am going to take that source code and run some script on it that's either going to build the database or run my unit tests or whatever, okay? It's going to do that on agents. So you have these build agents, and that's basically there for parallelization. So you have one piece of software that's responsible for kind of load balancing all of the tasks, and you've got these agents that you spin up to actually do the work of carrying out the test, building the database, running the tests on it, and then sending back the information. For example, Google, each time somebody commits to the Gmail codebase, basically an entire data center spins up with millions and millions and millions of VMs so that they can get through all of the tests in the Gmail codebase and send feedback back in 5 seconds before the next developer commits 10 seconds later. When you're Google and you have data centers at your disposal, that's quite easy to do. Most of us aren't quite so lucky. But in general, you scale with your build agents. That's where the actual testing happens. And you can set up your build agents differently for different purposes. For example, maybe the ones that are going to carry out your database builds have SQL Server installed on them. At Redgate, we have about 60 different build agents, but that's just because we've got 100 developers coding away all day. And we need that many build agents to get through all the work. But different organizations are going to need different numbers of them. And that's the commercial ones, that's typically how they license themselves, because typically the more agents you have, then the more work you're doing, the more value you're getting, so the more you pay. Okay, so that's how a CI server works, and that's kind of the task that it does. There are many of them available. Pick one. I did do a lightning talk at NDC Oslo about a year ago called Which CI Server is Right for Me. It is now a year out of date. If you watch it, then take everything I say about TFS with a pinch of salt, because since then they've released TFS 2015, which is way better than what went before. But that has also gone out on my Twitter as well, so if you look at the Twitter, and you'll be able to watch that one as well. It's just a 15-minute lightning talk, and it talks about all the different CI servers I mentioned before and the relative pros and cons. So that's CI, and now we finally get to the bit you all came for, how we're actually going to handle our deployment. Okay, so before we get there, let's have a bit of a history lesson. 15 years ago, any DBAs with 15 years experience will probably remember doing deployments a bit like this once upon a time. Maybe you still do it this way today. Somehow there is some change process. Somebody says deploy these changes to that server. The DBA has to work out what the changes are, write some script, and eventually run it on the target database. It was a long, boring, horrible process, and it took ages, and nobody really enjoyed it. Has anybody got any experience doing that? Yeah, was it fun? Yeah, okay. So a bunch of companies made some money trying to solve that problem by writing diff tools or change that could look at the two different databases, generate the script, and we've just saved you a whole bunch of time. Wonderful. Also, migrations-based frameworks solve this problem as well, because it means that the developers are writing the upgrade scripts at the very start. So by the time it comes to running them on production, it's a different way of solving the problem. It's just, well, I've already got the upgrade scripts. I can just read through them, check I'm happy with them, and off they go. So either a state-based or a migrations-based approach will help solve that problem now, because we already have the upgrade script when it comes to deployment time. Good. So that's good, except for the fact that that's not actually what happens. What happens in most organizations today is either your diff tool or your migrations framework is going to create the script that you want to run on production, and then some other poor DBA is going to receive that script and is going to have to run it on production manually. Yeah? People make mistakes. Has anybody here never, ever, ever run a script on the wrong database? I have. Yeah, that's just the first example off the top of my head. Okay, mistakes happen when human beings are left to carry out these actions. Now, there are some things that humans are good at, and there are some things that computers are good at. Making rational decisions based on experience and knowledge, stuff like, is it a good idea to deploy it now, or should I wait a bit based on the business needs? Those are human decisions. We want the human in the loop to make those decisions. We don't need a human in the loop to press F5. Okay, that is a task that is better handled by a computer. Okay, we worked out long ago that computers are good at handling boring, automated tasks in a consistent way. Those are the tasks that we automate, because I don't want to do that work. Okay, I'm going to make mistakes. And other people, we've talked about the drift problem already. So the process that we have right now, most of us, isn't good enough. Okay, the correct way, and this is according to me, with all of my authority and experience, I'm telling you the correct way to do a deployment is like this. First of all, we need to work out what our deployment artifact is. What is our source of truth? And the answer is not an upgrade script. And the answer is not a DAC pack that tells us a state that we want to get to. The answer is 4 things. I need to know the state that I want to get to, so I do need that DAC pack or NuGet package or whatever it is that defines where I want to get to. I also need to know where I'm starting. So I need 2 states. I need to know where I'm going from and where I'm going to. Okay, I need to know the start and the end destination. I also need an upgrade script that goes from one to the other. Okay, these 3 pieces of information are all important if I want to create a reliable deployment process. The next bit is kind of optional. It depends on your views. Some consistent report about what has changed, because different organizations have different cultures and policies, but a lot of the time it's a very common requirement for a human being to review what is actually being deployed to production and to decide whether it's a good idea or not. Ideally, they might also want to review the upgrade script. It gives some people some confidence to read it, or more likely have some sort of automated testing process where it runs against a staging database to make sure it all goes okay. That's a much better way to test a deployment script. But either way, this is what our deployment artifact should look like. Before state, after state, and upgrade script. Now actually, both a migrations framework and a state-based framework can provide all of this information. Okay, a migrations framework, if you just deploy everything from 0 to start state, and from 0 to start state and from 0 to end state, there you are. That's your before and after version. And the difference between them is your upgrade script. Fantastic. Migration scripts can do it. Okay. The other way, if you're using a state-based tool, well, that's straight from source control, that's straight from source control, and that's a script that either you generate or you write to get from one to the other. Okay. So it is possible to do this either way. But that's the minimum that you need as your deployment artifact. Okay. Then how does our deployment work? Well, first of all, we check. And this probably does involve using some sort of diff technology. Is the target database in the correct starting state? Before I even run anything, am I in the right state? Because if I'm not, drift has occurred, and I'm not going to run this upgrade script because of all the problems I mentioned earlier. Okay. Assuming I'm in the right state, I'm then going to run the upgrade script. I'm not going to generate new code at this point. I'm going to run exactly the script that's in the package. Okay, that means I can run this exact same deployment artifact against several identical databases, the staging database, the test database, and if it works on those, then there's a good chance it'll work in production. Okay, and then finally, I'm going to check, does it match the target? Okay, did my upgrade work? Because you know what? If there's a problem with this migration script, I'm not going to end up in the right place. And if that's occurred, I need to know about it. Okay. Now, regardless of whether this script has been written by a human being or by an automated process, I want to verify that it's worked. Okay. If all of that goes right, brilliant. Automated deployment, boom. But I want all 3 of those things to work before I'm happy with this being an automated deployment. I've got 3 points of failure, so what should happen in each scenario? First, if the target does not match the model, then I just error and I stop. I throw a warning. I say, look, this is where I wanted to start. This is where I wanted to stop. That's the current state on production. Use whatever software or tools you have to work out the differences. Maybe you've been using Redgate DLM dashboard and it will tell you what the changes are. But once you know what the problem is, you can start to think about what to do about it. If the script fails, well, your deployment script should be written in transactions, so it all gets rolled back, so that you either end up with everything deployed or nothing deployed. And finally, if at the end the thing doesn't match, well, rollbacks is another whole conversation. But what I actually prefer is to roll forward. So send the warning, work out what's wrong, fix it in source control, and redeploy. That's what I would do. But that relies on your cycle time being nice and short. Everything gets a lot easier with a short cycle time. Well, where are we up to in the time? I've got half an hour left. Yeah, we're about right. So that's how I want the deployment to occur. That's the thing that I want to automate, but I've not talked yet about how to automate things. I think we do have enough time. Does anybody have any questions at this point? I was planning to stop for questions at each one of these, and I've just remembered that. I'll take one question if anybody has one. Yeah, go on then. That's a very good question. For anybody that didn't hear, the question was, the build artifacts, do you put them in source control or not? Typically, that's what we use artifact repositories for. So I haven't actually covered it in a huge amount of detail here, but if you go to any of Dave Farley or Jez Humble's talks, who are the guys that wrote Continuous Delivery, they talk about this artifact repository being where you put the output of your CI server. The source control is for developers to manage the code and what they want the code to look like. But then the CI thing happens, and then out of that, it generates your NuGet packages, your upgrade scripts, the various bits and pieces that you need that make up that release artifact. And that all goes together into the artifact repository, which is kind of your the place where you go and pick up your deployment resources from. That's kind of how the chain works, and from that you should be able to kind of join the dots back to, well, this artifact is from build number 73, which goes back to this source control version, which solves this Jira ticket. So that should be enough. I guess the idea is that once you create your build artifact, you don't edit it. That's the same as drift if you edit the build artifact. So given that the build artifact is supposed to be immutable and not changing, I guess you wouldn't necessarily consider putting it in source control, because source control is to track the changes to a persistent set of objects, whereas your build artifacts are supposed to be a single immutable thing that comes out as a result of the code in source control. So typically no, but I don't think it will do any harm other than just slow you down and be a little bit more bureaucracy. Okay, I think I'll stop for one question at the end of each section. So if you've got any other questions, hold on to them. I just want to make sure we do get to the end. So let's talk about how to automate our deployment. This is the whole release management part here. So there's a whole class of tools called CI servers or build servers, and then there's another whole class of tools called release management tools. Before I talk about release management, I want to talk about another definition, continuous delivery. This is a phrase that's bandied about a lot. Again, this is from ThoughtWorks. They did literally write the book on this one, so I do feel a bit justified using their quote for this. Continuous delivery, CD, is the natural extension of continuous integration, an approach in which teams ensure that every change to the system is releasable and that we can release any version at the push of a button. Who would feel comfortable taking the head of their source control repository and pushing it to production right now? Okay, if you're shaking your head, you're not doing continuous delivery. Continuous delivery aims to make releases boring. So, well, yeah, that would. The idea there is that the implication is that you're doing continuous integration, and you have enough tests written into there that basically every time something fails, you write a test to make sure that thing doesn't fail again. Manual testing becomes significantly, if you're running the same set of tests manually before you go to production, well, that's something you should be automating. There's no point in having a human in the loop for that. Now, I'm not necessarily saying this is the right way to do stuff. I'm just saying that's the theory behind it. The argument is that if you put a lot more effort into your automated tests, then on average you're more reliable and are able to deliver more frequently with less bugs and less failed deployments. That's the argument. And there are a fair number of case studies that say it works. There are also a fair number of case studies that have tried it and it hasn't made a difference, but arguably they've not implemented it right, and hey, let's have a big debate. But this is the idea. So continuous delivery aims to make releases boring so that we can deliver frequently and get fast feedback on what users care about. And that's the key point. Like the quicker I can ship an update, the quicker I can get a small piece out, the quicker I can get feedback from the users about whether it's good or right, or if I need to tweak it slightly, and the quicker I can tweak it so that it is exactly what the customer actually wants, which makes me more successful, which means I beat my competitors and we all get rich. Now, that is the concept of continuous delivery. So continuous delivery is a much bigger business concept, whereas release management is a smaller segment of that. It is the technical plumbing of how I actually make that deployment happen. Okay, and in the same way that there are a bunch of CI and release CI servers, and I brought 6 of them up before, there are a whole bunch of different release management tools. Here's 3. Again, Visual Studio Team Services, top left. It allows you to kind of point to dev, QA, integration. This is Octopus Deploy, which has kind of taken the world by storm in the last few years. And we've got Bamboo down here, which is, I bring Bamboo up again, it's kind of a combined CI and release management tool. So you've got your build information on this side, and then on this side you can see where you've actually deployed the stuff to. So there are all sorts of tools that can help you do this, but they all work in broadly the same way. And that's basically like a CI server. So on the left, we've got the diagram that I brought up before of a CI server. You've got basically your CI server, which is like a load balancer. It gets the instructions and the trigger, and it sends out the jobs to the various different agents. A release management server does pretty much the same thing. The difference is these agents aren't there to manage the amount of work you have to do. They're your endpoints. They're the places you're deploying to. So you'll stick an agent on your dev server, an agent on your test server, an agent on your production server, and then what the release management tool is doing is it's receiving the instruction, deploy release 74 to test, and then it's going to find the artifacts associated with release 74, send them across to the test database, the test server with the instruction, run this script on those artifacts, and that is how your deployment will get executed. So it's the agent that actually carries out the execution of the deployment, and the release management server is basically the controller. That's pretty much how all of them work. They've just got a different UI on the front, and they do pretty much the same thing. There are differences, of course, between them, but that's broadly what's going on. It's not that complicated when you understand that. Okay. Now, again, I'm sorry you can't really see the grey outlines here, and that's supposed to say test, staging, and production. What I'm doing here is I'm mocking up an example set of environments that I want to deploy to, and now I'm going to define a few phrases and terminology. So first of all, I have my release management server, which is software that is running on a test or a build server or something. This is, as I say, the controller that's responsible for working out what scripts I'm running on what servers to handle my deployments. I have the machines I'm deploying to. Now these are my virtual or physical boxes where my system is hosted. Okay, these things are split into environments. Environments are collections of machines that I've got. Again, I don't know if you can see, this is the test one, the staging one, and the production one. So I've got a database and application server in a test environment, staging in a production environment in this example. And I have the agents themselves on the machines themselves. Okay, that's typically how it all works. Now let's talk about databases. Typically, the agents that we have on the database servers, we don't actually need them on the database servers themselves. That's because most tools that deploy the database don't actually need to live on the database itself. Visual Studio can connect to a database without living on the database server. Redgate can connect to a database without living on that server. So what we need to do is we need to install our deployment tool. I'm going to use this little symbol to define a deployment tool, whatever that deployment tool is. That is going to sit on a server with an agent somewhere that it can talk to these databases. So when the release management server sends a message to the agent, do the deployment thing now, the agent is going to do the deployment thing, and it's going to call your database deployment tool, which is what's then going to push out the deployment to your various databases. Does that make sense, or have I lost you all? That makes sense? Okay, cool. A lot of people choose to stick it all on the same machine. That's kind of fine. Some people will argue that it's not a good idea to put an agent and the server on the same machine because agents tend to run with higher level of privilege. For example, they can do things like shut down server, and you probably don't want that happening on your release management server. But yeah, you can pick exactly how you want it to work. What's more realistic is a scenario a bit like this, and this is where it starts to get a bit complicated, and this is why networking is one of the hardest things about release management. Okay, make friends with the person that understands your network before you try and do this, folks. Okay, because typically we have firewalls to contend with, right? Most people's production database is behind at least one firewall. So in this scenario, I have hypothetically put a firewall around the production domain, and test and staging are in the same domain. That's just hypothetically what I've done in this scenario. Might be a little bit not the ideal scenario. Of course, in a real world, everything should be really perfectly isolated. But in the real world, we tend to live with the means that we have. Now, your database deployment tool needs to access your target database. Okay? Which means for the production database, it probably needs to be inside the production domain. If I can't access the production database from my dev box, there's no point installing the database deployment tool there. I need to install it on the production box or somewhere in the production domain. It doesn't necessarily need to be on the database server itself, because we don't want to install too much extra stuff on the database server itself, but it needs to be in the same domain. Okay? And the same goes for the test environment. However many environments you have, you're going to need to install your database deployment software in each of those places. Okay? With an agent, because obviously the server needs to send the information to the agent to execute it. Now, this communication tends to be secure because any release management tool worth its salt is going to either encrypt it, or you're going to set up a firewall rule to allow it, or it's going to do it via HTTPS or something. So there's going to be some level of security there, and that's something that you're going to have to talk to your whoever is the administrator of the production domain, the network guys. You're going to want to make friends with those to actually negotiate that you're allowed to put this on. And then, but what it does mean is it rolls back. Your security for your production domain ends up coming back here, because if somebody can log on to this and send messages to production, you're locking that down as if it was production. But hopefully, by doing this, while this feels like a little bit of a security leak, actually what it means is if you do this, you can remove a whole load of people's rights to the production domain. And that's worth it, because everything that goes through the release management server is going to be logged. Okay, so this is a way of you can sell it, if you like, to the person that's responsible by production by saying, right, we'll do this, and then you can remove all of these people's access to production. Okay, so just in summary, because it's important to understand where all the bits and pieces go, we're going to install the release management server on a test server or a build server or something like that. We're going to install agents that will deploy applications on the application servers themselves. We're going to install agents that will deploy databases on a machine that has access to your target databases. And you're going to install your database deployment tool on the same machine that the agents that you will use to deploy your databases. Make sense? Cool. Any questions? Make sense? Potentially. I guess whether they have read access or write access is probably important. I mean, the troubleshooting what the problem is one thing, but then actually fixing it, in an ideal world, we're going back through our deployment tool to make that change. That's probably my response. I'm not necessarily talking about also, I'm not saying that you can remove every single person's access to the production server. That's probably a little bit too extreme. But there are certainly probably people that you could get away with. There are certainly people that you could probably get away with removing their access to production. That's something that definitely some of the people I have worked with have got it past their systems administrators, because it's been a trade-off. I'll do this, but I'll remove the developer's access to production because I don't need it anymore, because it all goes through Octopus Deploy or whatever other release management tool they use. Branching. So and the reason I bring this up is one of the first questions I always get when I talk to people about this, is they say, well, what about the scenario where I finish my work, but the other team hasn't finished their work, and so how do I deploy my changes without their changes? And how most people end up doing that is they go back to an old-fashioned way where they've got one team has got all of their upgrade scripts, another team has got all of their upgrade scripts, and then I can deploy the appropriate upgrade scripts when I'm ready to deploy the appropriate feature. Don't do that. Because when you do that, what you end up with in production does not match what's in source control. If what's on production does not match what's in source control, drift. And you end up with environment inconsistencies. You've never ever tested that particular thing in that particular state, so don't do that. So how do you solve it? Well, there are all sorts of different reasons to start branching. There's a very good blog post on branching called A Successful Git Branching Strategy. This is the blog post that has spawned Git flow, and I don't know about you, but that looks remarkably complicated to me for a team that's never started doing branching before. So I don't recommend that, but it's a very interesting read, and that's gone out on the Twitter. So if you're interested in reading that, go onto the Twitter and have a look at it. I've written my own blog post, which just tells you how to solve that problem. There are a couple of different branching strategies that you can take, and I'm going to give you the summary here. So the problem where some of the stuff is ready to go and some of it isn't, I'm comparing to the district and the Piccadilly line. Okay, two lines that run parallel to each other, and this is what we've done at Redgate on various different projects. All development happens on a branch called develop, or pick a name that's appropriate for you. And when you're ready to deploy something, you merge your changes over to the other branch. Okay. Now this isn't really continuous integration because we're not committing the thing we want to deploy to production several times a day. It's a pragmatic approach. It's not the ideal approach. But what it means is that I still end up with a version in source control that's labeled as the 3.7 release. And I can stick all my release notes and commit messages on the tag or whatever. Okay. And it means that I still have a version in source control that reflects production. I merge the changes I want to deploy into the production branch or the mainline branch. That triggers off a CI build, it builds my artifacts, and off we go to production. That's one approach. The other approach, which is also used in terms of release branches, is, for example, when I release version 9 of my product, I do a bunch of point releases, and then eventually I release version 10 of my product, and it's more for backwards, supporting backwards compatibility. If I need to be able to do a hotfix on version 9 because there's some security update I need to do, then I need to be able to go and get the later version of our software. So at Redgate we have this problem because, for example, our main product, every year or so we have a major release, and then we have incremental releases until the next major release, and you don't get the later version unless you pay for an upgrade or you buying support and upgrades. So we don't want to give away the latest version of our code just because some security patch comes out that we need to backfix for an old version. There are a couple of different branching strategies, and basically it's there to help you isolate one stream of work from another stream of work, but it means that you're handling the whole I want to deploy this feature instead of that feature problem in source control in the dev domain rather than in the production domain. It means it's all tracked. It means it's all source controlled. And it also means that you can integrate with governance stuff like TFS work items or Jira issue, what are they called? Jira tickets. So all of that sort of stuff can become useful in terms of, that's all useful. Stuff that's going to help, if you're going to do any branching, use a distributed version control system. Branching in a centralized source control system like Subversion is horrible. Actually, I say that merging is the horrible thing. Merging in Git is lovely compared to merging in Subversion. It's just to do with the way they work under the hood. A distributed source control system tracks the changes, whereas a centralized source control system tracks how it looks right now. Also on your own copy of the source control system, your own checkout, if you like, on a centralized system is just files, but on a distributed system it's its own local repository, so it can actually keep much better granular control of what I've changed versus what you've changed, which means when I come to merge it all better, just under the hood, distributed source control systems work way better when it comes to merging your problems. So if you have problems with different people merging different branches together, switch over to using a distributed source control system, and it'll make a lot of them go away. It's also a lot of relearning, because you need to completely relearn how the source control system works, and that is a learning curve you need to go through, and you will be slower in the short term, but in the long term it's going to help. Also, it's 2016. Okay. And finally, I mentioned this before, if you've never done branching before, don't do that, because you'll confuse yourself, it'll be complicated, and you'll get into a world of pain. The longer your branch goes, the longer you work on a different branch of the code before you merge it back together, the more complicated it is to merge it back, and that's exponential, it's not linear. Okay, so if you're doing it for a day, brilliant. If you're doing it for a week, if you're doing it for more than a week, just give up. Any questions on that point? How am I doing for time? Oh, I think I might finish exactly on time. Okay. So I've got some general piece of advice, and that's too many words on this. It's more to prompt me. Don't do all the things at once. I've talked about a lot of stuff in this presentation, and when I give a presentation like this, normally I'm miles away from where most of the attendees who are watching are, and they're like, oh, that looks like the dream, but in order to get there, I've got to do an awful lot of stuff. Don't try and do it all at once. Change happens in organizations slowly. You need to learn how to use things like source control before you start trying to throw release management servers at production. Okay, change happens slowly. You need to have time to learn how to do these things. If you've not got source control solved yet, start there. Work out which deployment tool you're going to use, whether it's a migrations one, whether it's a state-based one, whether you're going to use one of the hybrids. Feel free to come and talk to me later about the stuff that we provide, but I'm not going to talk about it here. So start with source control. Oh, and drift checking is another good place to start as well. That's something you can set up whenever you like, and that's going to help you be aware of just the changes that are happening in flight, being aware of when that change happens on production. I'm not necessarily saying you're going to have a slick deployment pipeline set up tomorrow, but at least if you know the problems are occurring, you can begin to have conversations with people about why the changes are occurring. Why do you feel the need to make the change on production right now rather than go through source control, and let's try and solve the problems one at a time. Don't forget tests. Too many people think that DevOps and automation and deployment is all about just getting changes from A to B. Well, it's all very well and good automating your deployment to production, but if you haven't tested it, okay, if you've not started doing any unit tests for your SQL and you have stored procedures, start. Okay, go to tsqlt.org and just start reading. Okay, the stuff is there, if you've ever made a change to one part of your database and broken another part of your database and not really sure why, well, start writing unit tests for the fragile and important parts of your database. You're never going to be able to write tests for your entire database because most of you have got legacy databases that are really horrible to deal with. But you can write tests as you go, and you can write some tests just for the most important and breaky parts of your database, so that next time when you commit to source control and you accidentally break something, you know as soon as you've committed to source control, rather than when you try to deploy to production and somebody calls you with an angry phone call. This is much more about teamwork than it is about tools and process. I've shown you the engineering part. I've shown you how we tie all the stuff together. But if people are still going to make changes on production because they believe that's the only way to do it, they're still going to do that. If the development team and the ops team aren't going to work together, you've got no chance of implementing a process like this that everyone's happy with. Typically, developers want to work in a model, a state-based way, and DBAs want to work in a migration-based way, because that's what they understand. DBAs understand upgrade scripts. Developers like to work with SSDT. You may well need to de-optimize your team in order to optimize the whole, and that's a good thing, because whether you like it or not, actually you're responsible for different parts of the same overall goal, which is to ship the changes that are needed to happen on the database and not to break stuff along the way. Collectively, you're responsible for that, so learn to work together. When you have a team night out, do you include the opposite dev or ops team? If you don't, start. Do you sit together? I wrote a blog post a while ago called "The Brick in the Wall." Don't be the brick in the wall. One place to start is if there is a physical wall between the database developers and the database and the DBAs, switch desks, sit next to each other. You know what? You might learn something. Typically, developers and DBAs have different areas of expertise, and they might not like to admit it, but actually there's some stuff they can both learn from each other. And that's a good thing to stick on your resume. Are you guys on opposite sides of the wall from the same company? Well, at least you came to this talk together. Don't use complicated branching strategies. I mentioned that before, especially if you're not using a distributed version control system. Just don't do it. a lot of people think a new branching strategy will solve all of my problems. They're mostly wrong. They normally cause more problems than they solve. They can be useful in certain scenarios, but don't do anything too complicated, because you'll just make your code base is complicated enough before you start having multiple different versions of it. Try to decouple your database deployments from other systems. If you've got 120 different databases with some horrible complicated dependency network between them, good luck doing this. Okay, if you can't build a database independently, it's going to be difficult. Now, there may very well be reasons why historically you've got to that point, but moving forward, it'll be much easier for you to ship changes frequently and reliably if you can test your databases independently. And that's not just other databases, it's your sys and SAS projects, it's the applications that talk to the databases, it's everything. Try and be able to deploy them independently. It just makes stuff like spinning up a new database for a new developer joining the team much easier. Books and concepts are a great start, but pragmatic decisions about how to apply them to solve specific problems provide real customer value. Okay, that's something I firmly believe in. Like, you can read all the books you like about continuous integration, continuous delivery. You can come to as many talks with me as you like, where I say that production drift is always a problem. But at the end of the day, don't just try and recreate a book. You need to look at what you have and solve the problems one by one that you have. Eventually you might end up with something that looks a bit like this, but don't just try and implement it exactly like I've said, because that's what I said. You need to take the principles and see how they relate to your organization, and basically if it doesn't help you deliver value to your customers more quickly, don't do it. Use the right migrations or state or hybrid. Ask me for help. Oh yeah, I was going to say what we did here. In the end, we kind of used a hybrid approach over here, so that both developers had their easy development process and DBAs had their migration scripts. We standardized everybody to Git, a distributed source control system. Everybody's using TeamCity and Octopus Deploy to release. They're also using some database tooling that I won't mention until after the show. And as a result, the company is not only are they releasing a lot more quickly now, a lot more reliably, but it's been taken as a model that at their sister companies it's being rolled out. And all of them have fantastic CVs and have moved on to much better stuff, because the database deployment was the bottleneck at that organization. It's now not the bottleneck. Now somebody else is a bottleneck, which means that these guys are all getting pay rises. I was told to put this session at the end. Apparently there's a raffle draw and an evening break and networking happening now. They're our sponsors. They're all great, especially one of them in particular, but I won't mention which one. That's me. I did have one shameless plug I wanted to put at the end. This weekend, I ran from London to Cardiff with a team of, well, it was supposed to be 12 people. It was 10 people. It was a relay race. It was hard. There was blood. There was sweat. There was tears. We got there in 27 hours. Children with Cancer is a charity that Phil, who is the guy in the white T-shirt here, it's special to him. Children with Cancer. If you'd like to donate, there's the link, and it's gone on the Twitter feed. If you'd like to speak to me afterwards about that, please do. It was a lot of fun. That's me. Thanks very much. I do have 5 more minutes for questions if anybody wants to hang around. Or feel free to leave. I'm not going to hold you here. So, sorry, what sort of performance checking was that?
Like sort of, so tying in the code changes or the script changes, tying that to performance monitoring, capacity monitoring. Is there been a way that you've done in the past?
So one thing, it's not database related, it's not SQL Server related, but it is a similar sort of problem. So one of our products is a tool called SQL Source Control, and typically one of the problems that our customers have had with it is the performance, because actually what's happening under the hood is several levels of complexity more difficult than what appears is happening. For various different reasons, it means that we're actually trying to do a very performance-intensive